We're going to be looking at this property of saccharides and disaccharides, which we call reducing sugars. And it's due to a structural feature within the saccharide itself, which allows the title to be used reducing or non-reducing sugar. And I've got several sugars here that I took off the shelf of the chem department. Here's glucose. Okay, now these are very water soluble, so they make great solutions. Okay, there's glucose. Fructose. Come on, let's go. There we go. Fructose. Lactose. You're familiar with lactose because you've heard of lactose-free milk and such things. Okay. It goes in there. This isn't quite as water soluble, as we'll see. And then I'm going to make 2 samples of sucrose. Now, sucrose is not like the others. Sounds like Sesame Street. Okay, sucrose does not react like the others, as we will see. But in any event, here we go. Okay, so we've got these 5 here, and I'm going to make solutions of them in deionized water. These dissolve very readily. And then here's fructose. Now, fructose is not like these others in that it is a ketohexose. In other words, it has a ketone rather than an aldehyde. And then lactose. It's not quite as I said, soluble. Okay, and then our 2 solutions of sucrose. Now I'm going to use a solution here of what we call Benedict's. This has been around for a long, long time. And what it does, it's a very strongly basic solution of copper nitrate in sodium carbonate. And the copper nitrate is going to be in a +2 oxidation state, as you can see, because the color of copper 2+ ion is blue. Okay, so I'm going to take each one of these, and I'm going to add some copper nitrate. Let's get fructose. And put it in the hot water bath. And let's get lactose. Okay, there's lactose. And then I'm going to do this. Now I'm going to do this with sucrose. It's going to be very obvious what the reactions will indicate. Now you can see that glucose is starting even now to show a kind of an orangey precipitate, which is characteristic of a copper 1 oxidation state. In fact, fructose is the champion of these. It goes very, very fast, and it's starting to turn this this color. Let's see, where's lactose? Lactose is slow. Sucrose, nothing seems to be happening. Let's just let them go for a minute. Okay. Now to the sucrose in this test tube, I'm going to put a couple drops of concentrated sulfuric acid. Make sure you wear your gloves when you handle this. Put that in there. Cap that up again. Dilute that down a little bit. Okay. So there we go. Notice, by the way, the fructose is almost completely orangey red. That's the copper 1 oxide precipitate that's formed. So we say that copper 2 ion has been reduced to copper 1 ion, and this change is very evident from the blue to orange color. And this indicates that that fructose has reduced copper 2 to copper 1. Therefore, we call fructose a reducing sugar. Okay, you can see here, glucose is almost the same. Okay, and it looks as though lactose is trying to catch up, and it will indeed catch up. Now, what I'm going to do, I'm going to heat up the sucrose that does not have any Benedicts in it. You can see the sucrose from the treatment with Benedicts is not changing color at all. Okay, and here we have sucrose. Let's let that go for a minute, and then I'll put the sucrose with the Benedict solution and see how that works. Okay. Well, see, the lactose is starting now to very clearly indicate that it's reducing the copper 2+ blue ion to the copper 1 oxide, which is a reduction. Okay. And still, the sucrose resists change. So let's see what will happen if I add some Benedicts to this. Whoa! You can see what happens. The acid that I put in there is going to make the carbonate fizzle a little bit. We'll see what happens. Now, glucose and fructose monosaccharides actually make up the sucrose molecule, and so sucrose is a disaccharide which is composed of glucose and fructose, and we've shown that glucose here and fructose, where are you, fructose? Fructose itself do indeed change and become change the copper 2 ion to copper 1. And let's give this a little time for it to convert. The pre-treatment with sulfuric acid actually had something to do with the color change that we're seeing right now. Here's the sucrose solution with just the Benedicts in it, and here's the sucrose solution which was pre-treated with sulfuric acid, so that it's starting now to change color and looking more like the 3 that we have here in this hot water bath. So I think if we just allowed this to stay in the heat a little bit longer, we would probably see an orange, but since we don't have that color yet, let's just wait. You can see after some heating that the color is starting to resemble the colors that we saw with lactose and glucose and fructose here. And this is the sucrose solution with Benedicts without that pre-treatment with sulfuric acid. So what the sulfuric acid did apparently was to expose an aldehyde group, which this basic solution did not. Okay. Okay. So I think that demonstrates that that sucrose is potentially a reducing sugar, but you have to pre-treat it with sulfuric acid in order to convert it as such. And you can see what happens when you don't. There it is.